We're going to finish our discussion about quadratic equations today, so I'm talking about completing the square. Completing the square, you couldn't have done your work yesterday with the quadratic equation unless somebody could come up with completing the square. And so these are a little bit backwards, but this technique is going to be good to know, because I'm sure some of you are saying, well, if I have quadratic equation, why do I need to know this? It's going to be good to know because some people actually find it easier, particularly easier than factoring. And the other things that we're going to use this technique when we start graphing parabolas and other conics, circles, ellipses, hyperbola, stuff like that. Because it's going to help us find the center points and the vertexes and stuff very easy, much easier, excuse me. So the intermediate goal here, we're going to talk a little bit about the hows and the why we're doing it, and then how to do it with two different examples. So our goal here is to complete the squares to make it a quadratic equation, ax squared plus bx plus c, into an equation that looks like this. Because then what you can do, remember, is if I take the square root of both of these, then now at this point I've got x minus 3 is equal to plus and minus the square root of 8. Why plus and minus? Well, because remember, I can take two different numbers and plug them in for x. And then if it's negative, I square it, I get a positive 8. If it's positive, I square it, I get a positive 8. The square root of 8 is 2 root 2. So when I add 3 to both sides, I'm going to get x is equal to 3 plus or minus 2 root 2. And that's your answer. Ta-da! So our goal is we're going to take an equation and turn it into something like that. So here is said equation. So we're going to take x squared minus 6x plus 2 is equal to 0 and solve it by completing the square. So as you can see, this isn't factorable. And now the first step of what you're going to end up doing is we're going to end up moving the constant term. Okay, we're going to isolate it. We're going to take this negative 2, and we're going to move it over to the side by itself. Okay. Because what our goal is here, remember what we're trying to do before, we're trying to get this down to something squared is equal to a number. And much like what we're doing with a lot of things in math this year, is that we're going to, if it's not fitting the way we want to make it work, we're going to make it work. We're just going to change it and deal with it. The second step to that is going to be factor out the value of a is not equal to 1. Now here, a value up here is equal to 1, so we don't have to worry about that. Next example will show you what's a little bit more involved. So now step 3, this is the biggie. If you do not forget this step. What you're going to do is you're going to take this b value and split it in half and square it. And we're going to add that on. So what we're going to do is, okay, so we're going to take negative 6 divided by 2. So that's equal to a negative 3. And what that's going to do is that's going to be the number that comes down here and makes our binomial squared. Because if I square this binomial, I'm going to get x squared, then minus 6x. Because remember, you multiply the two parts and double it. Now the only problem is if I do that, I've got this, so I've got x squared minus 6x. But if I do that if I multiply this out, what number goes right here? You need a 9, which does not exist up here in the original problem. But we can add it to one side. If we add it to one side, we have to add it to the other. Let me erase this. Yeah, let me make that actually something you can read. Okay. So when you do this, now what ends up happening is that we made this left side into a nice binomial squared. And we can do that because as long as you balance the equation, if I do it to one side, as long as I do it to one side, I can do it to the other, and we're good to go. Okay. So now I've got 7 over here. And then the last step is going to be factor the new quadratic into a square and solve. So this we already just basically did. This is kind of an idea where we're going. So now to solve this, we're going to go ahead, oops, apologies. Take the square root of both sides. So then this becomes x minus 3 is equal to plus and minus the square root of 7. So therefore x is going to equal 3 plus or minus the square root of 7. That, my friends, is your answer. Okay, so again, what we did, we isolated the variable, isolated the constant. We needed, in this case, we didn't have to factor out the a. We split the b value in half. The reason why we're doing that is we're trying to get this binomial down here. So we doubled it, and then, so we split it in half, and then we squared it. So it's like cutting in half, squaring it, and then we factored it and solved. Okay? So, and of course there's examples in your books that you can use for this as well. All right, now this one's a little bit. Now I've written the steps over here, and again, I would probably, I mean, obviously put those in your notes. I've isolated these a little bit so it's not so, or condensed them a little bit so it's not quite so wordy here. So the first thing that we need to do here is isolate the 27. And by the way, these steps are a little bit different than what your book goes through. These steps I find tend to make things not quite so crazy, and also are more helpful when we get into trying to set equations into vertex form or center form or things like that. All right, so we isolate the variable. Now, in this case, do we have to factor in an a? Yes, we do, because a is not equal to 1. So we're going to take the 3 out of just the left side. So this is going to become 3x squared plus 12x. I'm going to put some space here, because remember, we're going to add something in there. We're going to have to take half of this and do it, and then add it in. That's equal to negative 27. Now, again, remember where we're starting to go. Okay, it's always good to kind of have an idea of where you're going, because that way you can at least wander in the right direction if you're not sure how to get there. We're going to put down a 3x. Now, what binomial squared is going to give me x squared plus 12x? And this is where this is. You're going to take half and square b. So I'm going to take half of 12x, and that's going to become 6. Or half of the 12, and that's going to be 6. So again, this is going to become x squared, double this, which is double the product, which is 12x. So what I'm missing is, what? 36. Now, am I adding 36 on the left-hand side? The answer is no. I'm actually adding not just 36, but I'm adding 3 times 36 to the left-hand side. Because everything inside the set of parentheses is being multiplied through that 3. I'm going to select this up. Okay, so all of this then is going to be equal to negative 27 plus 3 times 36. That's going to be what, 72, 108, so 81. I didn't plan for it to be that nice, but it worked. So then to solve this, you can divide both sides through by 3. So that's going to become 27. And then take the square root of both sides. So x plus 6 is going to equal the plus or minus square root of, oops, you know what, I'm going to simplify that. Do you have to simplify these things? Yes. Why? Because A, is polite. B, I told you to. C, it impresses people at parties. Okay, so again, 27 is 9 times 3 squared of minus 3. And so then x, your final answer, is going to be the opposite of 6 plus or minus 3 squared root of 3. Okay, and that, as they say, is that. Okay, so again, isolated the constant. We factored out the a value. This is the part that once people get it, they seem to get it and hold on to it. You're going to split this number in half. So split in half going down, you square it coming back up. So half of 12 is 6, you square it. And again, the reason why we're squaring is because we need to make this perfect square binomial down here. All right, so then for what you're going to be working on in class tomorrow is going to be this, page 119, 3 through 11. 31 through 41 odd, 59 through 69 odd, 70 through 31 odd. Some of it's going to be quadratic equations, some of it's just going to be factoring, some of it's going to be factoring by perfect square. And yes, I do expect you to do that. Yes, I expect you guys to be able to show work on it. Okay, so none of this magic answers. See you in class. Talk to you later. Call up questions.